Assalamualaikum and hi everyone. My name is Sharifah Sofia binti Syed Saludin. My metric number is 2023-865-946.
Assalamualaikum. My name is Nur Aina Sofia binti Shanizam and my metric number is 2023-872-878.
Hi, Assalamualaikum. My name is Azwa Safrina binti Rumi Hussaini and my matrix number is 2023-868284.
Assalamualaikum. My name is Nur Aliana Zura binti Jahril. My metric number is 2023868048.
Assalamualaikum and hi, my name is Nur Adlina binti Anwar and my student ID is 2023866294.
The objective of this experiment to determine the coefficient of static friction of different surfaces. Introduction or theory of this experiment is vector quantities known as quantity that has both magnitude and direction, such as force and velocity. Velocity is the speed in a specified direction which gives object is traveling, while force exists when the object accelerates or undergoes a change in its velocity. Besides, if the body at rest or equilibrium, the forces that acting on the body is equal to zero. Gravity also exists in the frictional force. There is an attractive force between two masses that is called gravity. An object on Earth experiences gravitational force which is approximated as Fg equal to mg. The magnitude that exerted in the gravitational force on an object referred to as its weight. Other than that, a contact force known as the normal force that acts in perpendicular or in the normal direction of the contact surface between two objects. In addition, the force that opposes one surface in contact with another's relative motion is called friction. There are two types of friction which are static and kinetic. Static friction defined as the friction that acts on an object at rest, while kinetic friction is the friction that acts on a moving object. The maximum value of static frictional force is Fs max equal to nu Sn, while the kinetic frictional force is given by Fk equal to nu Kfn.
Apparatus that we use in this experiment is wooden block, 50 gram masses, 10 Newton spring scale, string, and tabletop. First, the mass of wooden block was measured and recorded as m. The apparatus was set up. The tabletop should be made sure to be stable and horizontal to the ground. The spring scale and the wooden block should be attached with a string and placed horizontally on the tabletop, making sure the rubber side of the block is faced downward. A 50 grams mass was placed on the wooden block. The spring should be pulled slowly. Once the block starts to move, the reading of the spring scale should be recorded and the value Fs should be tabulated in table 5.1. Step 4 until 5 should be repeated for 3 trials. Another 50 grams mass on the wooden block was added and step 5 to 6 will be repeated until a total of 500 gram mass is added to the wooden block. Step 1 should be repeated until step 8. This time, ensuring the rubber side of the block is facing upward. The data should be tabulated in table 5.2.
Now, let's take a look at the result. Here are the results and the data that we collect from the experiment. For the analysis of data, first, we have to draw and label the free body diagram of the wooden block. For the wooden block that have rubber surface facing the floor, there are three forces present: normal force, gravitational force, and frictional force. While for the wooden block with non-rubber surface facing the floor, there are only two forces present: normal force and gravitational force. Number 2, we have to plot a graph for static force against normal force for the rubber surface and non-rubber surface. Here are the graph. Based on the analysis, the graph tells us that friction force is proportional to normal force. Number 3, we have to use gradient obtained from the graph to calculate the coefficient of static friction for each surface. As a result, coefficient of non-rubber surface is lesser than coefficient of rubber surface. Number 4, we have to compare and discuss the coefficient of static friction obtained. The coefficient of static friction for a wooden block with a rubber surface is 0.5, while for a block without a rubber surface, it is 0.19. A higher coefficient of friction indicates more friction force relative to the normal force. Static friction refers to the observation that in usual takes more force to set an object in motion than to keep it moving once it has started. This implies that the wooden block without a rubber surface requires less force to move it than the block with a rubber surface.
Question 1. How can anti-lock brakes stop a car in a shorter distance than regular brakes? The answer is, anti-lock brakes keep the wheel turning, which means there is more friction between the tire and the road. When the driver slams on the brakes for an emergency stop, the car will stop more quickly due to a large amount of friction. However, the tires do not experience kinetic friction, but it will keep the stationary objects at rest. Once the static friction is overcome, the force of kinetic friction will slow down a moving object, which is a car, at the shorter distance. The larger the coefficient of friction, the greater the frictional force from braking.
Question 2. From your experiment, which material has the highest coefficient of static friction? Does this agree with your hypothesis? What do you think determines the coefficient of static friction? The answer is material rubber used to interact with the surface has the highest coefficient of static friction. This statement match with hypothesis created because rubber is very sticky substance and contains long chains of link to each other and strengthen them. Responded object of friction to floor determines the coefficient of static friction.
Question 3. Once the mass begins to slide, does it move smoothly or does it undergo stop and go motion? Explain the motion. The mass will begin to slide by undergoing stop and go motion. The motion undergoes stop because of friction. The velocity is decreasing. Friction is the resistance to motion created by two objects rubbing against each other. Thus, when the object slowly down, the acceleration is in the opposite direction as the velocity. From this, it will grip the wooden block from moving freely and cause slow pace movement till it stops naturally.
Okay, so we move on to the discussion part, which is, in this experiment, the wooden block with the rubber surface has the highest coefficient of static friction. This experiment was done to determine the coefficient of static friction of different surfaces. The coefficient of static friction could be determined from the plot data of the cross-Fisher curve of static friction force, Fs, against normal force N, for the rubber surface and non-rubber surface. The coefficient of static friction can be calculated with the formula F over N, which is F is for static force of friction, while N is for normal force. The gradients obtained from the graph was used to calculate the coefficient of static friction for each surfaces using the formula of gradient m equals to y2 minus y1 divided by x2 minus x1. From the graph of rubber surface, the coefficient of static friction is 0.502, while for the graph of non-rubber surface, the coefficient of static friction is 0.19. The difference between the coefficient of static friction of two surfaces is equal to 0.312. The coefficient of static friction for rubber surface is bigger than the coefficient of static friction for non-rubber surface. It is because bigger force is needed to pull wooden block on rubber surface and small amount of force is needed to pull wooden block on non-rubber surface. When the mass begins to slide, it moves to undergo stop and go. It is because the amount of friction that intersurface interactions can provide is limited. To prove this, the object's weight mg provides a vertical downwards which is called as normal force Fn, causing a friction force between the object and the plane. A body at rest remains at rest, or if in motion, it will remain in motion at a constant velocity unless acted on by a net force. An object will sliding across the table slow down and goes back due to the net force of friction acting on the object. While the experiment was conducted, there were some improvements that could be made. The observer should place their eyes perpendicular to the spring scale while pulling it. It is to avoid the error in reading that could affect the analysis of data. Next, take a set of reading by different observers during the observation in order to minimize the parallax error due to mistakes in reading scales.
Conclusion for this experiment. In conclusion, our experiment successfully determined the coefficient of static friction for various surfaces, revealing surface-dependent characteristics and influencing factors. The coefficient varied significantly between smooth without rubber and rough surface with rubber, emphasizing the nuanced dynamics of their interactions. The observed relationship between applied force and the onset of motion provided valuable insight into the critical forces required for overcoming static friction. On top of that, this knowledge provides a tangible and applicable understanding of frictional forces, offering insight that extend beyond the laboratory setting. It equips students with practical skill and theoretical knowledge relevant to various scientific and engineering disciplines.